At time t equals 0, a boiled potato is taken from a pot on a stove and left to cool in a kitchen. The internal temperature of the potato is 91 degrees Celsius at time equals 0, and the internal temperature of the potato is greater than 27 degrees Celsius for all times t greater than 0. The internal temperature of the potato at time t minutes can be modeled by the function h that satisfies the differential equation, where h of t is measured in degrees Celsius and h of 0 equals 91. A says write an equation for the line tangent to the graph of h at t equals 0. Use this equation to approximate the internal temperature of the potato. First, we can see there's 2 points, which is th and 0, 91. dh over dt is the rate of change, and the problem states that find the line tangent line. That means we need to use this equation. If we plug in the values, if you plug in y, the slope, and the x values, you can see that it gives you this equation. We can replace the y with h, and if you replace 3 in the t, since the question asks time t equals 3, you get an answer of h equals 43 degrees Celsius. B says use d squared h over dt squared to determine whether your answer in part A is an underestimate or an overestimate of the internal temperature of the potato at time t equals 3. To figure out if it's an overestimate or an underestimate, we need to first figure out if it's concave up or concave down. To do this, we need to find the double prime of h, but since it's respect to time, we come out with h prime. If you substitute f prime into the equation, you get the final answer, which is negative 1/4 parentheses negative 1/4 times h minus 27 close parentheses. Since this is always positive because the problem states that the internal temperature of the potato is greater than 27 degrees Celsius for all times t greater than 0. Therefore, we can conclude it will be concave up for all the time values greater than 0, so the tangent line is an underestimate. C says for t smaller than 10, an alternative model for the internal temperature of the potato at time t minutes is the function g that satisfies the differential equation, where g of t is measured in degrees Celsius and g of 0 equals 91. Find an expression for g of t. Based on this model, what is the internal temperature of the potato at time t equals 3? So if we want to find g of t, we need to integrate dg over dt. So we take the integral for each side. I put g minus 27 to the 2/3 powers below since to get rid of the negative. And if you do the integral, it turns out like this. Since we have c, we need to find out what c is. To find out c, we can plug in the initial value. It gives us g0 equals 91. So plug in the initial value, and if you calculate it, c turns out to be 12. Now we know what c is, we just need to write it as gt equals something. So if you clear out the values and do the calculation, you get an answer of gt equals parentheses negative t over 3 plus 4 close parentheses cubed plus 27. Now the only thing left is just plug 3 into t. If you do that, you get a value of 54.